Okay, hi guys. So this is your tutorial 2 for your building science and services part 1 lah. So this is here about lighting. Okay, so there's about 9 questions. Half of them is theory. So let's get on with the first question. So the first question is asking you to list out 8 lighting criteria. So this is to be considered in the design of lighting system lah. So the 8 lighting criteria is the light quantity, natural light, color quality, glare, directional quality, energy use, cost, and physical properties. So this can be found in your lecture slides. So I won't go much in detail about it, so you can have a read by yourself. So the question 2, give 4 factors which affect the amount or quantity of natural light inside a room. So the 4 factors is the nature and brightness of the sky, size, shape, and position of the window, refraction from surface inside the room, reflection and obstruction from object outside the room. So it's also will be in your slides. The next question, explain the following term. So there's 2 terms. The first one is daylight factor. So daylight factor is a ratio between the actual illuminance at a point inside a room and the illuminance possible from an unobstructed hemisphere of the same sky. Then next is the BSALI. So partially permanent supplementary artificial lighting of interior. So this is a system of combined daylighting and artificial lighting where parts of an interior are lit for the whole time by artificial light, which is designed to balance and blend with the daylight. So the fourth question is to discuss 3 principal components making up daylight that reaches a particular room inside a room, a particular point inside a room. So there's 3 principal, which is the sky component. So the light is a light you receive directly from the sky or the sun. And then the external reflected component, the light received directly by reflection from building and landscape outside the room. And internally reflected component, so the light received from surface inside the room. So there's a lot of component that makes up the daylight reaching a point in a room. Okay, so up to question 4 is all theory, which you can find in your lecture slides. So question 5 until 9 is all practice, tutorial practice calculation for you guys. So question 5 is about costing of the material for light. So the way to answer this is still the same. There's not much difference, just that the value is different. So you're given the question, it has given you that the total luminous flux required is 18,000 lumen for 2 years with 2 hours a day. So it didn't mention much, but if we just mention it like that, so we assume that it needs to be lit for 2 years, which is 365 days a year, 12 hours a day, and a requirement of 18,000 lumen. So that space it to have this sort of requirement. So you need to find out the difference in initial cost, replacement cost, and energy cost using the following. So you're given the following table. So you have your lamp wattage, 60 watt, lamp efficiency, 12 lumen per watt, and lamp life. So this lamp can only last for 1,000 hours. Installation cost, it costs about 2 ringgit each. Lamp cost 150 each. And finally, electricity cost. So it costs about 35 cents per kilowatts hour. So the first step you need is to find out what is the total number of lamp required. So for that, you need to multiply these two together, lamp wattage and lamp efficiency. So lamp wattage given is 60 watt and lamp efficiency is 12 lumen per watt. So by multiplying this together, you'll be able to find out the lumen for a single lamp. So as you can see here, output per lamp, which is 60 multiplied by 12, you get 720 lumen. So one lamp A is able to emit 720 lumen. So you'll be doing the same for lamp B lah. So you know your requirement is 18,000 lumen. So you just divide by what you have obtained here, 720. You get that you need 25 number of lamp A to light up this particular area. So you do the same for B, which is 15. Okay, so and then you need to find out the initial cost. So how much is it to replace and to install? So the first is the installation lah. So you need to make out the light point. So you know that you know that you require 25 number of lamp. So you need to install 25 light point. So installation. So all this installation cost 2 ringgit. So 2 ringgit times 25, you have 50 ringgit each. And then you need 25 of it. So 1.5 ringgit times 25, you have 37.5. So you do the same for lamp B also. And then we just add these two together, you have your initial cost. So your installation cost of your light point and how much your lamp costs. So you come up with a total of, for A, 87.5 ringgit, and for B, 202.5 ringgit. So duration to illuminate. So the second part is you need to find the total replacement cost, because the question is telling you to compare between lamp A and lamp B for you to make a decision. It's given a scenario that you need to choose between lamp A and lamp B. You're given 2 years and 12 the area to be light up for 12 hours a day. So that's why you need to multiply 2 years with 365 days, multiply by 12 hours, and you will have obtained the number of hours, which is 8,760 hours. So with that in mind, you just divide it by the lifespan of the lamp A lah, which is 1,000. So you get 8.76. So you do the same for B, but for the case of B, the lifespan of the lamp B is 8,000. So you'll get about 1.095. So for this case, the answer you get, you always want to round it up by 1. So because you require a total amount of 9 to last a minimum duration of 2 years. But because in your first initial calculation of your total initial cost, you already factor in the lamp cost here, which is 1.5 ringgit for 25 number, you actually do not need to have 9 number of lamp required. So you only need 8 because you initially already installed. So the total replacement cost is you need to have 8, and you know the cost per lamp is 1 ringgit and 50 cents, and then you need to multiply it by 25 because you need to replace all the lamp that you have in that area. So it will amount to 300 ringgit lah for replacement cost for 2 years. So you repeat that for lamp B, you get 82 ringgit and 50 cents for replacement cost for your lamp. And then finally, you want to find out the electricity cost. So how much it requires for you to light up this lamp to illuminate the area. So you're given 60 watt initially. So here you're given 60 watt, and this lamp B is running on 20 watt each lamp. So one lamp is 60 watt for lamp A, and lamp B is 20 watt. So we are to divide by 1,000 to make it into kilowatts, and we have to just multiply it by the number of the duration is required to lead. So you'll get the amount, which is 525.6 kilowatt hour. So with that, you multiply by the amount of number of lamp you required, which is 25, and you'll get the total of 13,140 kilowatts per hour. So finally, you'll use the last information given which is the electricity cost for this lamp A is 35 cents per kilowatt hour. So with all this, you just multiply them together again, and you will get that to run lamp A, it costs 4,599. So you repeat that for B, and you find that for B, the electricity cost is 919.80. So the total running cost for this, so at the end of the day, you just add them all together. Total running cost is the number of time you need to replace the lamp with the electricity cost. So you get about 4,899. And then finally, you want to add in the initial cost of the installation also. So you'll get about close to 5,000 for lamp A, and for lamp B, it's only about 1,200. So if the question asks you to give a comment or your which choice to choose, then you have to write it out. But for this question, it didn't ask, so you just end your answer at this point. It'll be good enough. Okay, so this is just a diagram for you to show you how is the calculation will be like. Okay, so next question 6. So you are given an area measuring 18 meter by 8 meter to have a service illuminance of 300 lux. So each of these has an output of 2,820 lumen, and then you're given a utilization factor of 0.4, the light loss factor of 0.8. So you'll find that you're given this info. So you just substitute the info into this formula that you have. Then you'll be able to find out the number of lamp required. So this is pretty straightforward. So the area here is the area here, 18 meter by 8 meter. And then you know that your E is 300 lux. Your F is equals to 2,820. Your UF is 0.4 and your LLF is 0.8. So you just compute it in your calculator and you'll get 47.87. So in this case, because it is a practical number of lamp, so you have to round it up which is 48 lamps. Okay, so question 7 is still the same. You're given an area of 10 multiplied with 6. So this is your area, length and width. And you are given n number of lamp, which is 18. And also F, which is 4,800 lumen, and a UF of 0.46 and an LF of 0.8. So you have to find out what is the E, the lux. So with all this information, so you just with this formula, so you just submit into the formula So you are required to move this formula to the other side of the equation. So I hope you guys know how to do it. And by putting all the formula and you computing the value, you get 529.92 lux. So you can just round up to 530 lux. So pretty straightforward. 6 and 7 is the same. Just it's asking you to find the average illuminance in the classroom. Okay, so question 8. So question 8 is still the same, but you need to find the utilization factor. So you need to find the utilization factor first. So you're given an area of 12 meter by 6 meter, and additional info of that. The height is 4 meter, but the workbench is 1 meter high. So the discharge each lamp is 3,700 lumen. They are fitted in aluminum industrial reflector at ceiling level. So for the HM, to find the utilization factor, you need to find out the room index, the RI. So this is a formula to find out the RI. So with the to find out the RI, you know your L and you know your width, and then you know your HM. So HM is basically the distance of your light from the workbench, which is 3 meter here. So you just use 4 meter minus by 1 meter. You get your HM. So you put it all in, you'll get your Ri equals to 1.33. So based on the table 6.4 utilization factor for some luminaries, you know that your reflectance for ceiling is 0.7 and reflectance for wall is 0.5. And given your Ri is 1.33. So here, the reflectance of your ceiling is 0.7 and the wall is 0.5. So you know it's around here. And then the description of the fitting, you're given that your lighting fitting are equipped with the aluminium industrial reflector. So it's at here. So ceiling, wall, your fitting, and then you have your Ri. So it's about 1.33. Let's just say it's you take 1.25. So comparably, you will get 0.56. So your UF is 0.56. So this is how you get your utilization factor from the table with all the information you are given. So finally, with all this information, you know your UF, which is 0.56, your light loss factor is 0.7, and then the rest of the information you put it in, you'll be able to find out that you need 20 number of lamp. Okay, so finally, the last question you need to find out the daylight factor. So you're given your E1 is 430 lux and EO is equals to 5,380 lux. So by just dividing them together and multiplying by 100, you know that your daylight factor is about 8%. So you just substitute the formula in with all the factors given and you'll get your answer. So that's about it for your practice for your tutorial 2 for lighting topic. So hope you guys understand, and if you have any questions, so please feel free to ask now or you can type it out once you're done.